Hi students, the 10th sum in the textbook exercise. Calculate the gravitational field at a point O due to three masses m1, m2 and m3 whose positions are given by the following figure. m1, m2 and m3 are shown in the figure. O is the point. If the masses m1 and m2 are equal, if suppose m1 is equal to m2, then what is the change in the gravitational field at the point O? It's a very simple question. First of all, you must know that if one mass is given, surrounding the mass there will be a gravitational field, and at one point there will be a gravitational field due to the given mass. Suppose if that point lies between two different masses, then at that point there will be two gravitational fields, which is the algebraic sum of the gravitational field due to each mass. Similarly, now you can see the point O is lying between three different masses m1, m2 and m3. But they are at the same distance A. A is the distance of the point O from m1 as well as m2 as well as from m3. So at this point O, there will be three gravitational fields. So by the principle of superposition, the gravitational field or the net gravitational field at O we have to find out, which is equal to the vector sum of the gravitational fields due to the individual masses. So I will take first the gravitational field at O due to the first mass, that is denoted by E1 vector. So E1 is equal to capital G into given mass m1 divided by the distance square is a square into, since it is a vector, it is acting along the positive x direction. So it is a I cap. The direction is unit vector along the x-axis is I cap. So next one is E2. So that is G into mass m2 divided by same distance square. So m2, this is attracted towards the x dash axis or negative x axis. So this is minus I cap. And the third one, so E3 vector, gravitational field due to the third mass. So this is equal to capital G into mass m3 divided by distance square is the same, but it is attracted along the y-axis. So the unit vector along the y-axis is what? J cap. So this is a J cap. So what is the net gravitational field? The net gravitational field at O is given by E is equal to the E1 plus E2 plus E3, the vector sum of these three factors. So now I will write E vector is equal to, the first one is what? G m1 by a square into I cap. The second one is minus I cap. So minus of G m2 divided by a square into I cap. And the third one is plus G m3, okay, G m3 divided by a square into J cap. Now the common factors I can take G by a square. So E vector is equal to G divided by a square into, okay, into m1 I cap minus m2 I cap. So that can be written as m1 minus m2 into I cap plus m3 into J cap. So this is the final expression for what? The gravitational field at O. இப்போ இந்த சம் நம்ம எப்படி செய்யணும் அப்படின்னு பார்த்தீங்கன்னா, ஃபர்ஸ்ட் புரிஞ்சுக்கணும், ஒரு மாஸ் இருந்ததுன்னா ஒரு பாயிண்ட்ல ஒரு கிராவிடேஷனல் ஃபீல்டு தான் இருக்கும். அதே பாயிண்ட்டை சுற்றி 2 மாஸ் இருந்ததுன்னா அட் த சேம் பாயிண்ட் 2 கிராவிடேஷனல் ஃபீல்டு இருக்கும். இப்போ படத்துல 3 மாஸ் இருக்குதுப்பா. அந்த 3 மாஸ் இருக்கிறதுனால ஓங்கிற பாயிண்ட்ல எத்தனை கிராவிடேஷனல் ஃபீல்டு இருக்கும் அப்படின்னு கேட்டிங்கன்னா 3 கிராவிடேஷனல் ஃபீல்டு இருக்கும். அது E1, E2, E3ன்னு எடுத்துக்கிறேன். அது மூணுமே வெக்டர் ஃபார்ம்ல எழுதணும். அதுக்கப்புறம் அந்த 3 வெக்டரை ஆட் பண்ணோம்னா அதுதான் ரிசல்டன்ட் கிராவிடேஷனல் ஃபீல்ட் அட் த பாயிண்ட் O. அப்படிதான் நம்ம செஞ்சிருக்கிறோம். புரியுதா? அப்புறம் இதுல என்ன கொடுத்திருக்காங்க? if the masses m1 and m2 are equal, அதாவது if m1 is equal to m2, அப்ப இந்த கிராவிடேஷனல் ஃபீல்ட் என்ன ஆக போகுது? இந்த டேர்ம் m1 minus m2 will become 0 தானே. அப்ப இந்த I cap term இருக்காது, மிச்ச டேர்ம் இருக்கும், அவ்வளவுதான். அப்போ m1 minus m2 is equal to 0 இல்லையா? அப்ப that is equal to 0. Therefore the net gravitational field will be equal to gm3, okay, g into m3 by a square into j cap. இதுதான் ஃபைனல் ஆன்சர் நமக்கு தேவையானது. ஓகேவா? புரிஞ்சிடுச்சா? I hope you have understood well. Fine.